The last section discussed the elements of the geometric algebra G3, multivectors. This section discusses the operations on those multivectors. First up is the inner product, dot product of two vectors. It's defined to be the length of the one times the length of the other times the cosine of the angle between them. This is a scalar. Three properties. If U and V are parallel, then their inner product is simply the product of their lengths. If they're parallel, the angle between them is 0. Cosine of 0 is 1, so the cosine term drops out. If two vectors are orthogonal, their inner product is 0. If they're orthogonal, the angle between them is 90 degrees. The cosine of 90 degrees is 0. And last, the inner product commutes. V dot U is equal to U dot V. The outer product U outer V. The outer product of two vectors is a bivector. Now a bivector has an area and an orientation. The area of the outer product is the area of the parallelogram shown. For the orientation of U outer V, follow the direction of U around the parallelogram, U being the first element in the outer product, giving a counterclockwise orientation as shown. I emphasized earlier that bivectors have no shape, but outer products, special kinds of bivectors, do. They have the shape of the parallelogram here. Three properties of the outer product. If U and V are parallel, then their outer product is 0. If U and V are parallel, then the parallelogram they define is degenerate with area 0. If U and V are perpendicular, then the area of U outer V is the length of U times the length of V. In this case, the parallelogram defined by U and V is a rectangle with sides U and V, and hence with area length of U times the length of V. And finally, the outer product anti-commutes. V outer U is the negative of U outer V. The parallelogram defined by V and U is the same as that of U outer V, and so the areas are the same. But for V outer U, for its orientation, I follow the direction of V around the parallelogram, giving a clockwise orientation. The geometric product U, V. The geometric product of two vectors is the sum of their inner and outer products. This is the fundamental product of geometric algebra. What makes it tick? Two properties. If U is parallel to V, then we know from earlier that the outer product of the vectors is 0, and so all we're left is the inner product. And in this case, we also know that the inner product of the vectors is simply the product of their lengths. If U is perpendicular to V, then this inner product drops out, and we're left with the outer product. Since the outer product anti-commutes, in this case, so does the geometric product. G3, the products. We now know how to take the inner, outer, and geometric products of any two vectors in G3. It's time to see how these operations operate on general multivectors in G3. First, The geometric inner and outer products can be extended to all the multivectors in G3. For example, I can take the outer product of a vector with a bivector. The operations obey the distributive law. As shown, the open circle represents any one of the three products. The geometric and outer products are associative, obeying the law shown. Non-commute or anti-commute in general. This completes the description of the geometric algebra G3. It's time to learn what we can do with it. This is taken up in the next sections.